Okay, let's get started. Excuse me. That's how you know it's live. Okay. So let me close out of this and get back to the project. So where are we? Where did we leave it last time? Let's check our to-dos. Well, we did that. And we did that. Yes, we did that. So now I have a function by MIME type, right? So I've got the ability to, if we go to the database, I have the ability to find my image data by date, location, tags. Let's see, and by MIME type. And I think that's good enough for now. So let's talk for a second about the layer cake. So if we go back to my vision of what right and proper applications should look like, we have the database layer at the bottom, right? That's Postgres. We have whatever web service layer on top. And then we've got the layers that we control in the middle. Those are the data access layer, which we've been implementing. The logic layer, which what I've been doing is try to support the concept of an image in my logic layer. And then we've got the server interface layer. So we are going to move back to the logic layer. That means going back to the image. And why do I have broken things in here? Okay. So we have to fix this up for our changes. So we'll start. Let's go ahead and close all these windows. They're just creating clutter at this point. Okay, so we need to fix up our mock data layer. We have time, location, tags. So we have just going to fix this up as quickly as we can right now. Mock metadata server. Let's go take a look at mock metadata server and see what's wrong with mock. Nothing's wrong with mock metadata server. So, new image repository. Oh, I see. This probably does not implement, yeah, it doesn't implement Find My MindPack. So we can do and it's going to have the same basically signature as all my other Finder methods. Okay, and the test is green. So now we need to go back here on the implementation and get it to green. From a source standpoint, awesome, okay. So what's the last broken thing here? Okay, so now if we run okay, so we picked up the, I believe is the correct. Cannot resolve symbol DarkInk. Interesting. Let's go make sure it's live on the interwebs. Yep, and there is data. Okay. Get rid of that. Let's go ahead and quit out of this and restart it. Let's bring it into its own. There we go. Why can't it resolve that? Terminal. So this is server. Cannot convert nil to data.metadata server. Well, that should be an interface. So that should be totally conversant with nil. Unless, of course, it can't resolve the import, right? So why is this import failing? Why is this failing now? GitHub.com. There's data. Huh. So we can't resolve this import. What if I run and go? If that's it, I'm going to be kicking myself that I just needed to do a go get. Okay. Now we should be cool. And we are cool. So let's go back to image test. What does find mock metadata server needs to implement find, and it does. Context metadata query returns. Not exactly sure what the issue is here. Maybe there's some other issue that's masking it. Okay, let's see, getting rid of all our issues. We still have this issue. What is data 2? I think I suspect, this is just my suspicion, when I added the module file, I changed, when I added this module file, I changed this from being just a subdirectory of this to being its own repo kind of thing. So now I need to treat it slightly differently. So that's why I think it worked before and didn't work now. But that's just my guess. I'd have to research that. All right, so we're back to green on this. So if we run image test, we're green. Okay, good. So now let's talk a little bit about how, so we have this notion of an image. The image has some sources. What do we have in source? Source is, fine. It's fine. It's fine for now. We've got some query parameters. We have an image repository. So conceptually, so let's think about this for a second. So I've got some piece of code somewhere. Let's open up this. Uh, so we have this chain of things that needs to happen. And it starts by creating some pool. So some connection string. So actually what we do is we get the connection string from environment variables. So we get that and we create it. Right, so let's go ahead and skip the error for now, just to avoid having to deal with the error processing. So we create it takes a PGX pool. Oh, Well, that's good. Oh, parse config. So that creates a new DB caller. That winds up creating a new metadata server, and that creates a new image repository. Now we have, some handler, and that takes a response writer, request, and so somewhere in this function we need to get hold of an image repository, right? So for this, let's say for example, so let's so we get, say for example, so we got the so we got some requests to find by location, for example. So let's call this find by location handler. So this is some HTTP handler sometime in the future, right? So we're going to get the location from the HTTP request. Great. Then we are going to do, assuming we have, let's just some repo. And this is simple dot repository. So we're gonna at some point call some repo dot find and some query parameters. Right? So this is we need at some level to get a hold of this image repository, populate that. Now, during our main startup, of course, I fully expect to allocate a pool. If we can't allocate a pool, what do? We stop, right? We can't. If we don't have a database connection, we can stop right there. What else do? We do some general housekeeping, like there's some registering of, and I have another video on this, on custom types. So we need to register our custom types. We need to register any specific prepared statements that we might have, etc., etc. So we take care of that. Then we instantiate a new DB caller. Now, why do we have a DB caller? We have a DB caller, so our database interface is in part because it's mockable, in part because it allows me to abstract some of this, some of the database calls and how I manage them. But so I've got this DB caller, and I can go ahead and create that. And conceptually, I might have another, I'll have other servers along with the metadata server. I'll have, maybe a Don't know at this point, but I'll probably have some other servers. And then I need to set up my repository, right? So one option is just in the code that relies on this. I could say, I could have var image repo right, and then down here I would just say repo find, right? So that's all well and good if everything's in the same package, and it very well could be, but again, going back to hopefully not 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 without merit harping on this concept. So where would this code sit? Obviously, the stuff that implements handlers and so forth, that definitely sits up in here. So this would not only be the web server layer, but it would also really be all the stuff that gets me a request that I can process, right? And this is the code that sits in here in the server interface layer, where we're pulling data out of the request and we're passing it in here. In fact, we could even go one step further, right? We could have a search request and a right, and we could have a specific endpoint like type interface searcher. So we'll call this image searcher, and it's an interface, and search takes a context, and it takes search request, and it returns a search response error, right? And so this layer, the layer that we have here, is even the pink server interface layer. This layer gets even more cleanly separated from the web server layer, where we hook it into the web server layer. By having, an image searcher, and then doing air equals search. And this will be search request, right? And then we have the if error fill blah blah blah. And then we have search. We have search response template. Encoding template. So we have the search response template. Cute. And result. So we have something like this. So we have something like this. So my handlers become very formulaic, right? So I don't have to think a lot about how to. I just have to. I really, really get down to this. This interface defines what my web service supports. It supports a search request and provides a search response, and has the image searcher capability. And my handler just becomes extract the parameters, build the request, execute the request, and process the response. So that kind of drives the thinking out of the handlers in a way, right? The handler can then really just focus on what a various, for example, one of the things that people don't think about a lot is because I think a lot of detail percolates up into the handlers unnecessarily, is what does an error mean? So for example, if I have a service, and I request an image, and I don't own the image, we could return the message saying you're not authorized. But maybe just knowing that the data exists is a sensitive issue. Like for example, I could wind up searching for you could have an API, for example, that brings up information about people by their email address, and you have a stalker that is using it to find information about somebody, and what they care about at this point is to know whether or not they've registered with your service, and so they're just trying to see if they get a 403 or a 404 when they ask for their victim's email. So that is a situation where you may want to say, okay, normally we would return a 403 in this case, but that would leak information about the fact that this person registered with our service, and our service is extremely private and contains sensitive information, and we don't even want to disclose this person registered with us, so instead of returning back a 403, instead we return back a 404. And the logic being that within the realm of things that you own, the data that you own, it has not been found in the data that you own. Um, Not just is it anywhere on a server, but is it in the data you own? So when we have to do a lot of work up here and have to deal with more lower level details, uh, we can lose some of that error handling. The error handling just becomes part of a large blob of 100 lines of code. Uh, it might be difficult to spend time on it, but if it's the error handling is, especially if we have utility functions like um, extract, search parameters, and it takes a request and returns back a search request. So in this case, what we do is so now we can really focus on stuff like, well, what should I return as my error? How should I handle my error? And from the endpoint, that's really super important, and it also gives me the ability to frees me to be able to correctly do timeout and cancellation, uh, because I don't have other code that I need to deal with. The other code is gone because I abstracted it all away, and I can really focus on what makes the interface between this layer that I don't really control and this layer where I do control cleaner and more elegant. So that does mean that I'm pushing the handler code more up into this layer. So handler code. So it means that this is migrating from here up into the low part of this, for example. But it means that this is a more interesting layer, right? And I mean, there's a certain point at which you can add 55 layers, right? We could have the layer that prepares the web server layer request to the service layer request, which prepares it to the so the handler code belongs here, and we have request processing in here, and we have, and I'm rambling this morning, model model model-based code here. But we could have 55 layers where I have the web server layer, the handler processing layer, the service interface layer, the statement of work layer, the logic layer, the data independence layer, the data, multiple data access layers. So I could have many more layers. So why is this a magic number of layers? Why is 5 any better than 3 or 7? And it just comes down to the basic problem of how can I reduce the complexity here to a reasonable point where I don't get much more benefit by pushing uh, abstractions into a new layer, and what I clarify in this layer by moving that code out. And so I think I'm leaning towards this approach, and to create an actual service layer, and have the service layer having a service package, for example, in here. I think that makes more sense. And then the handlers will just exist in here. But that does raise so we could have a type new image searcher. And what would that take? That would take, of course, a image repository. It returns back an image searcher, right? So we would have to set up right, so now we're back into our dependency injection problem once again. We've just moved it down a layer. So now the image searcher, which is the thing that our handlers will call, right? So it wouldn't be a big deal to have all our services. So we could have image searcher, we could have maybe some sort of, maybe have some authentication services and so forth. It wouldn't be that big a problem or stretch just to have these as variables at the kind of main implementation. But we do need to set it up with a repository. That repository needs to be set up with a metadata server, which needs to be set up with a DB caller, right? So all these things have to get populated in, and it becomes a little bit of a it's not a problem that's been solved all that well in Go, right? So if you've got Java, of course we've got dependency injection, and if I could just say, my handler pass in an image searcher, which would get constructed using dependency injection on the constructor with an image repo, which would get constructed from a server, which we had instructed from a pool reference. And so this stuff has been thought out for me. I will have to set it up as I build out my application. Now this I create, this is I create one, and it's application wide, right? The metadata server, if it's stateless, I can do one, and it's application wide. And for the image repository, again, as long as it's stateless, now what I haven't covered here is the concept of a transaction. So we're dealing with SQL databases, and one of the benefits of an SQL database is I can have a consistent unit of work, right? I can say, create a new metadata record with these encoded images, and the three tables I need to update are all updated together or not at all. Or for that matter, if I'm taking a bunch of images and tagging them as need to archive or whatever, I don't run into a situation where half of them are untagged because the transaction failed. The transaction is either going to, all the work is going to be done or none of the work is going to be done. And when we get into some of these, we will need to be able to say, hey, great, you're using we need to create a new maybe repo which creates its own server um, in order to respect the bounds of a transaction. So this isn't by any means, this isn't the final solution by any means. And while it looks simple and it looks reasonably portable, it doesn't handle things like transactions very well, which we need to come back to. And so it's not that these things are stateful, it's that they're in a specific unit of work which must all complete or not complete at all. So as I start thinking about this, I kind of already want to move these classes as literally as thin as it is into a folder called logic and make it its own thing. And then deal with it from there. But definitely within the context of, say, an image repository, we might be updating multiple tables. And so when we use a metadata server, we need it initialized with a database connection from a transaction, not the standard database connection. So this isn't necessarily the pattern that's going to work for us. But I will think about that later. I think that's it for today. And I think that's going to be something I'm going to noodle on over the next 24 hours or so and try to figure out what I want to do there. All right, I will see you later.